My name is Jacek Janczura. I'm a software developer, and I'm co-author of the paper DeCoCo blockchain-based decentralized compensation of digital content purchases. This paper was written in cooperation with Code University and Professor Peter Ruppel and Technische Universität Berlin, Marcel Müller. This is a paper written for the second conference on blockchain research and applications for innovative networks and services Brains 2020. In this paper, we present a novel approach for decentralized e-commerce workflows and a blockchain-based architecture with cryptographic tokens is used to represent a content ownership and execute compensation for the transfer of cryptocurrency. My name is Jacek Janczura, and let's start. This is the agenda of this presentation. Let's start with introduction. In the era of Web 2, centralized multi-sided platforms such as Amazon emerged. They are called multi-sided because they benefit both creator and buyer. In the picture, we can see both Helga, the buyer, and William Shakespeare, the creator. Thanks to those marketplaces, buyer receives a precise recommendation of products, and the content creator benefits from that because it increases the number of sold units. Sounds good, doesn't it? Let's imagine Helga. Helga wants to read Hamlet. She goes to Amazon, she pays for the book, she downloads the book to her Kindle e-reader. Now she can read the book on Kindle. Done, easy, perfect. From the creator perspective, it looks lovely as well. He places the book in Amazon, and he is compensated by Amazon each time someone buys Hamlet. At this point, both Helga and William are locked in. When Helga wants to migrate to other provider or some other better e-reader appears, she loses all the books gathered over the year. It's called data format lock-in effect. Apart from that, Helga is paying monthly subscription in Amazon. In case she wants to migrate, she will be forced to pay monthly fees until the end of the year. It's called channel lock-in effect. When creator wants to change the platform, they end up in losing all position in search engines and position in recommended products. Build reputation upon the years needs to be built from scratch. It's called data-driven lock-in effect. Moreover, those platforms don't offer transparency to the creator. Shakespeare doesn't have tools to verify if the received compensation corresponds with actual number of sold books. The same principle holds for music, videos, or pictures. The trust and the mutability of decentralized databases are the keywords, and the technology called blockchain and smart contracts seems to answer it. Let's go deeper into the lock-in effect and what is wrong with these multi-sided platforms. So where is the lock-in effect in these platforms and why it's bad? The big marketplaces wants to prevent both buyer and creator from migration to their market competitors by locking them in within their services. In those platforms, we can differentiate four different lock-in effects, as I mentioned before. Data-driven lock-in effect. It means that if user wants to migrate, they lose the place in ranking search engines and results and credibility. Pricing powered lock-in is happening when vendors are forced to accept the fees, which can be changed by MSPs. Data format, it's a classical DRM. We restrict access to digital content by only for our products, in case you can read books bought on Amazon only on Kindle. And channel lock-in effect. We encourage the users to subscribe so they cannot quickly migrate to our market competitors. Okay. In contrary to big multi-sided platforms, we separated actors and allow them to interact with each other as separated entities that have different roles in the system. In DeCoCo, different entities are acting in one or more roles. The more entities involved in the process leads to a higher level of decentralization, Before I jump into the architecture, let me introduce the roles in the system. In DeCoCo, we can identify 6 roles. The buyer is the actor that buys the product. Distributor is an actor that distributes the product and allow buyer to download the encrypted version of the product. Authorization manager distributes only the keys to encrypted to the encrypted content. Merchant is a marketing expert, and he works only on a client discovery. He doesn't host any kind of complicated any kind of complicated delivery system to deliver the and verify the user. He's only doing marketing. And creator is responsible for the deployment of smart contracts and writing the smart and preparing the digital content. And of course, one entity can serve multiple roles. For example, distributor can be as well authorization manager, so they just deliver the content without encrypting and sharing the keys and so on. And of course, all of it can be done behind the scenes in the backend and between the REST calls or within the set of some kind of headers. Okay, in DeCoCo, we implemented the set of smart contracts. Of course, I won't talk about it in here. Let's simplify it. In here, we can see that there are 3 contracts: content token, SLA contract, and SLA factory. Merchant want to distribute the creator's content, and they sign up SLA contract where they state all the details of corporation. Creator then deploys such a contract for each merchant, and those contracts are allowed to mint digital cryptocurrency tokens to the buyer's account. One cryptocurrency per one content. So for example, if we want to distribute Hamlet book, we'll create a Hamlet token, and all the merchants will mint this Hamlet token, so the creator can cooperate with Amazon, so distributed Amazon or eBay. When someone triggers a buy function and transfers the required amount of money to that contract, the contract mints the token automatically and compensates all the third parties saved in smart contract. So the payment of the royalties and all the fees is done automatically by smart contracts. And creator deploys 1 contract per merchant, but all that contracts mean the same token per content. This SLA, so sales level agreement, can be changed dynamically, and if a content creator is not satisfied with the services of merchant, distributor, or authorization manager, they can easily switch to different provider. So the system doesn't create possibility for a strong lock-in effect. This is the flow of the data in the system, and you can see for buying the content, and you can see the displayed graph that merchant is separated from distributor and authorization manager. And in DeCoCo, apart from blockchain, there is no single point of failure, and the actors are strictly separated with each other. And instead of explaining these 21 steps of purchasing the content, let me simplify the whole process and depict the main idea behind the DeCoCo. Okay, let's start. Let's start from a deployment of the smart contracts and sharing the content. Let's imagine William. William Shakespeare shares the encrypted version of Hamlet with Booksy Delivery and the decryption key with Superkey, the authorization manager. Then he signs the agreement with Amazon that Amazon will be eligible to sell Hamlet and distribute the merchant contract. And creator deploys the smart contract for Amazon in blockchain, where he places the Amazon wallet as the merchant. Amazon, as an expert and excellent marketplace, reach Helga and allows her to discover Hamlet. Helga buys the Hamlet, paying with cryptocurrency, and in exchange she receives a Hamlet token. All 4 parties are automatically and transparently compensated by the smart contract. Then Helga can request Booksy and Superkey for Hamlet and prove that she bought it using the digital Hamlet token. And since it's a blockchain, she can just provide her signature with her private key to prove that she actually owns the tokens. The system complies with EU regulations, where EU allows or like enforces all parties to resell the digital licenses. And when merchant wants to distribute the creator's content, they just sign up the SLA contract where they state all the details of cooperation, and creators deploy such a contract for the merchant. So this is pretty simple. So let me show you a demo of what we built. We implemented the set of websites where to show that this is really distributed, and to show that there actually is a Booksy that delivers the content, and SuperKey that is authorization manager, and Amazon that is marketplace. But in reality, it can be created within the set of headers. So Helga don't need to go to Amazon, Booksy, and SuperKey. She just downloads the key directly from Amazon. This is the MetaMask. MetaMask is a key manager for blockchain. We can see Helga owns around 99 ethers, and she doesn't have any Hamlet tokens or Romeo and Juliet tokens. In here, we can see the accounts of merchant, creator, deliverer, and distributor, and key authority, and that all of them has 100 ethers. Let Helga buy the token. She discovers the Hamlet at the Amazon, and she is pressing a buy button at the website. Then MetaMask automatically opens, and it allows Helga to pay with Ether for the book. She confirms the payment, and right now she owns one Hamlet token. We can see it as well in MetaMask, that right now Helga owns one Hamlet William Shakespeare token. And the third parties, creator, merchant, and distributor, have been compensated. Let's go to SuperKey, the authorization manager. Helga can log in within her blockchain address by providing a signature with her private key. So SuperKey is sending her random string. She's signing the random string, and it means that she owns the blockchain address and the Hamlet tokens. Now she can download a key since she's properly authorized. Let's go back to Amazon. We downloaded the decryption key, and let's go to Booksy. In Booksy, we provide a signature as well. We log in with our MetaMask, with our blockchain address. We sign a string. Booksy verifies the signature and allows us to download Hamlet. Of course, Booksy as a distributor distributes thousands of other books, but since we bought only Hamlet, we are allowed to download only encrypted version of Hamlet. So Booksy doesn't own the decrypted version of book, neither does authorization manager SuperKey. So let's download the book. Now we can decrypt the content. This is an encrypted version of the book. And as soon as we decrypt the book, we can display that actually instead of decrypted stuff, there is actual book, Hamlet. Let's go back to the presentation. Where is the transparency? Since we used smart contracts, this is the transparency. We can see in Etherscan and in a blockchain that within one transfer of 1 Ether to the smart contracts and triggering by function, it corresponds to 4 transfers to all the parties that are cooperating within the system. And you can download the code, run it yourself, and see the smart contracts on my GitHub repository. We implemented everything, and you can read the code yourself. Okay, evaluation. This figure shows that the total accumulated cost of running the scheme on top of Ethereum blockchain. And in this paper, we proved that the deployment is negligible within the higher number of transactions, the deployment cost, of course. And the most important factor is the transaction fee in the Ethereum. And apart from that, with the current transaction fees, for the item cost that is costing €5, we'll pay around 3 cents of fees in Ethereum. And we compared that to PayPal, which is the biggest payment provider. And we proved that PayPal for now is 10 times higher, and the fees in PayPal are 10 times higher than the fees that you pay within the DeCoCo scheme. And as we all know, the gas price fluctuates for Ethereum. And in case of DeCoCo, we proved that even though with the increase of gas price, the deployment fees are still negligible. Apart from that, we've got some other findings, but if you're interested, please read the paper. What about the security and this part of the evaluation? The system buyer is pseudo-anonymous wallet number for us, so we don't need to store any data because it's a transaction between wallet to wallet. The system allows only a license holder accessing the digital content because only license holder can provide a signature with the private key. By decoupling the encrypted content and the key, we make unauthorized access much more complicated, and the third parties can access at most encrypted content or encryption key. And if the third parties want to cheat on a creator, the distributor, so the party that owns the encrypted version of the content, and authorization manager needs to cooperate. And blockchain itself guarantees integrity of the system. In this paper, we proposed an approach for decentralized e-commerce workflows. DeCoCo splits business logic in purchasing content of digital content and distributes it between different roles. A blockchain-based architecture with cryptographic tokens is used to represent content ownership and execute compensation through a transfer of cryptocurrency. Furthermore, DeCoCo gives a content creator the possibility to freely adjust their collaborators and partners without lock-in effect. And the future work. Will be centered around the direct integration of concept into web protocols. I can imagine integration of DeCoCo into existing standards with extended set of HTTP headers, so all the transactions and all the confirmations can happen behind the scenes. Additionally, integration with off-chain payments and state channels such as Raiden Network, Perun, and Counterfactual Protocol will be required, and successful integration will result in much higher scalability of the protocol in both transaction throughput as well as much slower transaction fees and much lower latency. And we are currently implementing the first version of Decentralized Marketplace, which will be released within the next few months. And for centralized marketplaces, there exists already incentives such as W3C payment request API candidate recommendation. And this protocol needs integration on similar level, so DeCoCo, such that buyers can purchase the content licenses directly via their user agent in seamless fashion. The other points for future work you can read in the paper. Thank you very much for your attention. Right now it's time for questions. My name is Jacek Janczura, and thank you very much.